Yes, Shivam, I'm audible to you.
यस सर।
यस, आज क्या स्टडी किया है आपने? कुछ नया टॉपिक पढ़ा?
सर पढ़ रहे हैं जीके चालू
ठीक है,
किए
आप
हैं।
सबसे ज्यादा ज्योग्राफी और जियोलॉजी पे फोकस कर लीजिए। बाकी हिस्ट्री वगैरह तो कोई अगर हो जाए तो ठीक है, नहीं तो कोई बात नहीं, लेकिन ज्योग्राफी और जियोलॉजी, यूपीएससी, इन पे ज्यादा फोकस कर लीजिए, ठीक है ना, क्योंकि ये ज्यादा इंपॉर्टेंट है कंपेयर टू अदर।
तो सर जियोलॉजी और
जियोलॉजी,
जियोलॉजी वाला
ज्योग्राफी
सबसे
और
ज्यादा पार्ट,
यूपीएससी। यस।
तो जैसे अर्थ से रिलेटेड चीजें, एटमॉस्फेयर एंड स्पेस, ये सब चीजें मैंने थोड़ा पढ़ा हुआ है।
थोड़ा बेसिक कर लेना, आपने पढ़ा होगा जीएस वगैरह में, लेकिन सबसे ज्यादा फोकस कीजिए उसका जो कोर मेंटल क्रिस्टल है ना, कितने टाइप की कोर है उसमें, किस टाइप के मेटल्स पाए जाते हैं, क्योंकि जीएसआई का मैटर है ना। तो उसकी कितने डिस्टेंस है, किलोमीटर कितना अंदर गया हुआ है, कौन कौन से मेटल है, कौन कौन सी लेयर है,
ये सब तो
कितनी
सब पढ़े
बनती
हैं।
है, उनपे कौन कौन से मिनरल्स पाए जाते हैं, कोर मेंटल क्रेस्ट पे क्या क्या पाई जाती है, क्रेस्ट पे सबसे ज्यादा कौन सी गैसेस पाई जाती है, ये चीजें उनको थोड़ा डीपली पढ़ ली। एक दिन लगेगा मुश्किल से, लेकिन हो जाएगा। ये ज्यादा जरूरी है, ठीक है ना।
ओके।
यस। लेट वी स्टार्ट। बेसिक इंट्रोड्यूस योर सेल्फ।
Hello, myself Shivam Yadav. I'm from Varanasi. I have done my 10th and 12th from Hagia Singh Academy, and I have done my graduation from Banaras Hindu University. And I have completed my MSc from IIT-BOM.
यस, लास्ट डे वी हैव डिस्कस, लास्ट टॉपिक इज
So thermo,
थर्मो। थर्मो टॉपिक लास्ट।
so third ला पढ़ लिए।
थर्ड लो।
क्लासेस क्लैप प्लान हो गया।
क्या क्या हो गया?
तो क्लासेस क्लैप प्लान हो गया।
यस 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 यस। मैक्सवेल रिलेशन, do you have any idea about the Maxwell relation thermodynamics? What the main application of Maxwell?
So Maxwell relation give us idea about the relation between different thermodynamic quantity to solve the thermodynamics problem easily.
पर्पज क्या है मैक्सवेल रिलेशन का? जो एंथैल्पी, एंट्रोपी, गिब्स फ्री एनर्जी, इंटरनल एनर्जी, जो रिलेशंस हैं उनका क्या पर्पज, क्या है, किस तरह से वर्क करते हैं, व्हाट द वर्क ऑफ दिस रिलेशन इन थर्मोडायनेमिक्स, हाउ टू वर्क इट?
Purpose, the purpose is to calculate the different quantity like heat capacity, pressure, and different things.
कोई यूजेस है? व्हाट द यूजेस ऑफ मैक्सवेल रिलेशन इन आवर सोसाइटी, ह्यूमन बीइंग, एनी बेनिफिशियल पॉइंट?
No idea, sir.
ड्रॉबैक, लिमिटेशन? शेष बताइए।
Drawback.
Okay, no problem. You look them. You have to study. Yeah, I will send you the answer. Next one is जूल थॉम्सन इफेक्ट. व्हाट इज जूल थॉम्सन इफेक्ट?
The Joule-Thomson effect is a thermodynamic phenomenon that describes the temperature change of gas and liquid.
जूल थॉम्सन इफेक्ट और जूल थॉम्सन कॉफिशिएंट, क्या डिफरेंस है इसमें?
So basically, Joule-Thomson coefficient is used to describe the Joule-Thomson effect.
यस, जूल थॉम्सन इफेक्ट फॉर्मूला क्या है इसका, कैसे निकालते हैं हम, क्या आइडिया?
Uh, so we can calculate mm, del T by and del T by del P equal to minus CP ब्रैकेट में del H by del P.
यस, जूल थॉम्सन कॉफिशिएंट पे आइडियल म्यूजेटी जो वैल्यू है वो जीरो होती है, रियल के लिए पॉजिटिव है, अदर वन इज नेगेटिव है अगर मेरा प्रेशर अगर हाई करते हैं, तो ये क्या कंडीशन है, क्यों ऐसा है, तो मतलब रीजन क्या है इसके?
So region.
ओके, नो प्रॉब्लम, रुक दे. इन्वर्जन टेम्परेचर क्या है, व्हाट इज इन्वर्जन टेम्परेचर?
So inversion temperature is the temperature when mu jet is equal to zero, where the gas there like the ideal gas.
यस, थर्मोडायनेमिक्स के लास्ट टू क्वेश्चन, व्हाट द मेन बेनिफिशियल पॉइंट ऑफ थर्मोडायनेमिक्स, होल थर्मोडायनेमिक्स इन ह्यूमन लाइफ इन आवर सोसाइटी, बेनिफिशियल पॉइंट.
beneficial for. Through thermodynamics, we can know about the temperature of any body, how much the substance or body are hot or cold, uh, and we can know about the energy efficiency of any body, how much efficient can work any body. We can also design a vehicle through thermodynamics. Through thermodynamics, we can design different engine according to study after the study of thermodynamics. We can know about the chemical reaction, which reaction is spontaneous, which reaction is non-spontaneous, and we know about the where the heat can transfer through the thermodynamics.
The drawback, disadvantage of thermodynamics, whole thermodynamics.
Will go off. So we cannot able to get any information about how fast the reaction are going. We only know about the reaction is spontaneous or not.
Yes, or many other. Okay, no problem. Next is chemical kinetics. Chemical kinetics we have discussed here left.
Left.
Yes. What is the main application of chemical kinetics?
The chemical kinetics give us information about reaction, how reaction is reaction, which reaction is fast, which reaction is slow. Uh, it gives us information about the which type of intermediates are formed. It gives information about intermediate states.
Yes, chemical kinetics. What is the difference between rate law, rate equation, rate of reaction? Describe one by one.
The rate, the, rate equation is a empirical mathematical expression for the rate of reaction to express the concentration terms to express the reaction in terms of a concentration. And the rate law is a mathematical expression to show how the rate of reaction are depend upon the concentration of the reaction. And rate constant are the probability constant that is specific to the particular reaction at a particular temperature.
Yes, first one is basic point is what the difference between order of reaction and the law of thermodynamics.
Order of reaction and law of thermodynamics.
Yes, zero order of reaction and zero law of thermodynamics. Difference.
The order of reaction basically give the information about rate of chemical reaction and concentration of the reaction.
Yes.
While law of thermodynamics are the principles which describe the behavior of the system.
Yes. Heat. What's the difference between order of reaction and molecularity?
Order of the molecularity basically is the number of molecules that take part in a chemical reaction in a rate determining state. And order of the reaction is sum of power of the power to which the reactant concentration are reacted in a rate like reaction. And molecularity is always in whole number, and the rate of reaction and order of reaction is it can be zero, negative, and positive and fractional. And molecularity is applicable only for one step reaction, and order of reaction is applicable for complex reaction and simple reaction also.
Yes. First of all, zero order of reaction. What the main application of zero order of reaction?
So, so zero order reaction is basically a reaction in which the it is independent of concentration of the reactant. Uh, so we can see the application in Haber process, formation of ammonia, where zero order that is zero order reaction.
Next one, first order of reaction. What the main application of first order of reaction?
The first order reaction, the first order reaction is the reaction in which the concentration of the rate depend upon the concentration of the reactant to the power one, and it can be it can be helpful to know about the nuclear reaction. All the nuclear reactions are first order reactions, so it is very beneficial to understand the first order reaction.
Second order of reaction. Yes. Application. And third order.
So, second order reaction application, we can say that ozone depletion is a second order reaction. So it is very beneficial to understand the second order reactions to know about how the ozone depletion are happening.
Second order, third order. Yes, what the half-life of zero order, first order, second order, third order? Half-life.
The half-life for zero order reaction, the half-life of zero order reaction is uh, uh, a naught by 2k, and for first order reaction is 0.693 upon uh, k, and for second order reaction is we can see that 1 by 2 a naught k. And for third order reaction, we can say 3 by 2a square k.
What the difference between first order of reaction and pseudo order of reaction?
The first order reaction is the reaction in which the concentration depends upon the reactant to the power 1. But in pseudo first order reaction, the reaction is basically the second order reaction, but the concentration of one of the reactant is very high in comparison to the second. That's why it is negligible. So it is considered as a second order, pseudo first order reaction.
Yes. Next new topic is first is what the example of reaction is zero order, first order, second order, third order.
So example of zero order is we can say that decomposition of ammonia. We can say that ammonia decomposed into N2 and S2 is a zero order reaction or decomposition of HI on a board surface. First order reaction is all the nuclear reaction are first order reaction, and we can see that decomposition of S2 in H2O is a first order reaction. Second order reaction is conversion of ozone into oxygen is a second order reaction.
Yes, ammonia process is zero order, first order, second order, SN1, SN2, and third order.
Third order, third order नहीं नहीं याद है.
Third order example 2NO plus O2, 2NO2, 2NO plus Cl2, 2NOCl. Next new topic is activation energy. Yes, what the main application of activation energy?
So activation energy give us idea about how much energy are required to change the molecule from the reactant into product. It is basically the minimum amount of energy required by a reactant molecule to participate in a reaction. So, activation energy we can know about any how much energy required to change the reactant into product.
Is what the difference between activation energy, threshold energy, and actual energy in chemical kinetics? Difference and uses.
This activation energy is a minimum amount of energy required by the reactant molecule to participate in a reaction, and threshold energy is the uh, total amount of energy required from the total amount of energy. Basically, it is activation energy plus initial potential energy of the reactant molecule.
Next is what is the Arrhenius equation? What the main application of Arrhenius equation? And how to determine the activation energy value from Arrhenius equation? Describe. Yes.
Uh,
Calculate.
Next equation is basically a k is equal to a e to power minus ea by rt. It is uh, the relation between rate constant and activation energy. So please repeat the question.
Yes. How to determine the activation value from Arrhenius equation?
So we can calculate activation energy by the formula k is equal to a e to power minus ea by rt. If we differentiate it, we get a formula log k t2 upon k t1 uh, is equal to ea by 2.303 r 1 by t2 minus t1. Here through this formula we can calculate the activation energy.
Is what the difference between Arrhenius equation and integrated Arrhenius equation?
The integrated Arrhenius equation is calculated when the two different temperatures are given in a reaction, and Arrhenius equation is as the absolute equation in which at a particular temperature you can calculate the activation energy.
The formula of what the formula of integrated Arrhenius equation formula.
Ln k1 by k2 is equal to E by r 1 by t2 minus 1 by t1.
Next one is catalysis. What is catalysis? What the role of catalysis in Arrhenius equation?
Catalysis is basically used to increase or decrease the activation energy of the reaction. And there are two types of catalyst: a positive catalyst and negative catalyst. A positive catalyst has a function to reduce the activation energy of the reaction, so that the reactant easily change into product and get the product easily, and we get the product. And negative catalysts are used to increase the activation energy of the molecule.
Next one new topic is steady state approximation. Yes, what the main application of steady state approximation and what the difference between steady state approximation and equilibrium approximation? Describe one by one.
The steady state approximation is a chemical kinetic analysis that is used in a variety of applications. Like it is used to study the enzymatic behavior. and we can also see the application in ozone reaction.
Yes, what the main purpose of steady state approximation in chemical kinetic?
The steady state approximation is basically used to understand the to study the complex reaction uh, in easier if a reaction is happening more than one step, more than two steps, and one step is is very is existing very for very less time, then it is beneficial to find the rate of reaction using steady state approximation.
Yes, any drawback, limitation of steady state approximation?
नहीं पता
Lindemann theory, what the main application of Lindemann theory?
sir. The Lindemann theory is basically to explain the enzymatic behavior of the how the enzymes are used. Our enzymes are applicable in human body. How it is work in human body. The Lindemann theory explain that behavior.
Yes, what the effect is, Lindemann theory is very low pressure and high pressure. So what will be the reactant product of order of reaction?
Sir, for low concentration, it is a second order, and for high concentration, is a first order.
Yeah, low pressure is second order, high pressure is first order.
First order.
Any drawback limitation of Lindemann theory?
Need testing.
Okay, no problem. Next one is a Michelmanson equation, enzyme catalyst.
The the Michael Menton Michael Menton constant is the Michael Menton catalysis is basically explain the enzyme catalysis.
Yes, Michael Mendelssohn is greater than substrate and Michael Mendelssohn less than substrate. Michael Mendelssohn equal to substrate. What will be the order of reaction?
Sir, if Michael Menten is less than substrate, so the rate of reaction formula is K2 E naught S by Km plus S. If substrate is greater than Km, then rate of reaction is equal to K2 E naught. That is all they then get consumed, and R is R max. And if the substrate is less than Km, then its formula comes to be rate of reaction is equal to K2 E naught S by Km. And third is if Km is equal to substrate, then in that case rate of reaction is equal to K2 E naught by 2.
Yes, any drawback, limitation of enzyme catalyst, kinetic of enzyme catalyst, any drawback, limitation?
So it is only applicable for single substrate reaction. If the substrate have more than one substrate, then it is not applicable.
Yes, what the line beer work method? What the main application of line beer work method?
नहीं याद है भाई.
Next one is collision theory. What the main application of collision theory?
So collision theory is basically it basically helps us to understand the rate of reaction. It is helpful for calculating the rate of reaction of the complex reactions. It is applicable for the reactions in
Who by develop
between.
Arrhenius and want of? Is what the main purpose of collision theory and drawback, limitation of collision theory in chemical kinetics?
There are lots of drawback of collision theory. So he does not explain he does not explain the uh, any equation for the rapid chain reactions, and